Hey everyone! Today we will be learning how we can make 2D games run super smooth, even with hundreds of sprites appearing on the screen. So don't worry if you're new to Godot, I will explain everything step by step, and without further ado, let's just get started right away. So first up, we want to make a new project, and we want to go ahead and choose 2D for the render options. Now, if this is something you want to incorporate into your own project, I suggest just following along as well, because it might help you when you actually do the steps instead of just looking at this yourself. So let's go ahead and prepare our test sprites. I have already made some sprites, very simple and very ugly, but I just made three different versions. One is going to be a high resolution, so something like 256 by 256. One is a medium resolution, that's 128 by 128. And then we have a low resolution, which is 64 by 64. So I will just import this into my project here. Alright, so as we can see, I've imported these sprites down here. Just three simple sort of badges, I guess we could call them. I just made it simply in Piskel. But you can get these three sprites if you want from the description to just play along, or you could use your own sprites, but you'll have to update them into three different resolutions. Alright, so if we have imported all three of our sprites, we want to make sure that under project settings, we have the rendering, which is under rendering here, and then textures. We want to make sure that is set to nearest, so that way our pixel art actually renders properly and doesn't look all blurry. Then let's set up our base scene here. So what we want to do is we want to make sure we just have this set as main. We want to make sure we already save this because we'll use this later on. Then right here, we want to make sure we add a player, which is just going to be a simple player, so it's not going to be anything too fancy. We'll just add a character body 2D as a child of our main node. And then we want to make sure that we add a camera 2D on the player, and we also add a sprite 2D. Now for the sprites, we'll just use the default Godot icon as the sprite for the player. Then what we want to do is we can just go ahead and start coding already. What we want to do is we want to make a new scene, which is going to be the dynamic sprites we'll be using, so the three different resolutions. So we'll just name this dynamic sprite. Then we want to add three different sprite 2D nodes. So we'll do that right now. You can hit Ctrl D twice to just duplicate the item. Then one will be in the high resolution, one will be in medium resolution, and one will be in low resolution. And then we want to make sure we attach the sprites to the right, sprite 2D node. There we go. And then we want to make sure we save this as dynamic sprite.scene. So now we will need three different scripts, and I will show you exactly where to attach them. So first up, we want to make the player script so that we actually are able to move around, so that I can show you the example a bit better. So on the main node of the player, we just want to attach a script. We can call it player.gd, that's fine. And then we want to set up a little bit of a basic movement functionality here. There we go, just some basic movement so that we can use it later on. So we first just get the direction and we set it to pretty much nothing. Then we get the axes of the x value, which determines if we go left or right, and then the same for the y value. Then we normalize our direction and just apply a velocity based on the direction and the speed. So then we'll get to the main functionality, which is for our dynamic sprites. So over here we want to make sure we do the same. We attach a script and we just go ahead and create it. We can get rid of the basic code. Then what we want to do is we want to add an export variable, which will basically go ahead and hold the thresholds for when we want to swap out the different resolutions. So in this case, we'll keep it simple. I'll just do it by increases of 200. But in your game, you might want to do it differently. That's something I'll leave entirely up to you. Then in here we want to make sure we go ahead and add all of our sprites into this array. Then inside our ready function, we can actually get started with the coding here. So we want to make sure we get the high res at the start, so it always starts at the high resolution. So that way we want to loop over every single one of them. Do you want to make sure that we set them to be visible so that everything is invisible at the start, sorry. And then we want to make sure that the first index will be visible, which should always be our high resolution, right? So if you have it set up where the high one would be the last, you might want to change this to 2 and so on, but that's pretty obvious. Then we go into our process function. Now in here we want to make sure we get the distance to the camera, and we want to also make sure that we update the sprite resolution. So first up, let's just get the camera. So we can do this by getting the viewport first, and then there's a simple function that's get camera 2D, which will just do what it says. It'll get the camera that we have set up. And then if there is a camera, we just want to get the distance, which would be done by getting the global position, and then we can do distance too, actually. And then we want to make sure we do it to the camera.global position. So that way we have the distance, and then we want to make a separate function, so update sprite resolution. That's a good name. And then we want to check culling camera, which is also something we'll create, and I'll explain later on when we actually get there. First up, let's make the update sprite resolution function. So we want to go ahead and do func, which takes a distance. It won't return. So what this will do is we will loop over all of these sprites and just hide them in the beginning. Whoops. Then what we want to do is we want to make sure we actually go ahead and show the appropriate resolution based on the distance. So this is just going to be some if statements. So if the distance is less than or equal to the first one, so 200, we want to make sure that we set the high resolution. Then we want to create an elif, and then you pretty much get what I mean. So this will be the first index. Then we want to make sure the medium resolution is showing. And then for the last one, we could just do this in the else. We make sure that low resolution is visible. So that would be when we are further or furthest away from the actual sprite. We don't want to attach too many resources to that, so that way we just keep the performance optimal. Then now for our check culling function, we get the camera 2D. That's fine. I'll just keep it like that. Then we make sure we get the viewport again. Wow, I can't type. So we get the viewport rect. Then we need to make sure we get the camera position. So we can do that by doing what we did before, is the global position of the camera we passed along. Then we want to get the view top left and view bottom right to just check if objects are in view. So let's go ahead and do top left first, which is just the camera position minus the viewport rect size, and we'll just divide that by 2 so that we should end up on the top left. Then we have the bottom right, view bottom right actually. So then we do the same but on the plus side. viewport rect.size divided by 2 as well. And then we want to have a couple of if statements to just go ahead and check if an object is in view. And if it is outside of the view, we want to disable the processing. So we do this by first getting the player, or I mean the position, sorry. And then we want to go ahead and do some if statements. So if the position of X will be less than the view of the top left, or greater than bottom right, yo, hold up, whoops, I didn't mean to put that there. And then the same for the Y values. We will set process to false, and we will also set the visibility to false. So what we do here is we first check the X values to see if it's outside of our view, right? So it'll be outside of our view if it's less than the X value on the top left, so it would go behind there. And then the same for if it's bigger than the bottom right, so it goes out of the screen at the bottom right. And then we want to do the same for the Y values to just check if it doesn't go outside of the view as well. So then we want to set the processing to false. And if it's not, we simply want to go ahead and set it to true again. There we go. So now for a little bit of an optional thing you could do is actually go ahead and debug the visualization. So for this, we could use the draw function, and we actually go ahead and do an if statement to check if the editor hints is enabled. So now we just draw a simple circle to actually show you when we actually debug the scene here, which we'll do in just a minute. But first we'll have to create the spawner script, which is just going to spawn a whole lot of sprites so that we can actually test it out. So then back in the main scene, we want to create a simple node2d, and we want to name it spawner. And on here, we just want to create a script or attach a script. And we want to go ahead and define two variables, which will be the number of sprites we want to spawn. In our case, we'll just do 200. And then the area it can spawn in. Which we'll just set to 2000 by 2000. Then inside of our ready function, we want to make sure we initialize the different sprites, right? So we first want to get the dynamic sprite scene. So we preload and then get the dynamic sprite scene. And then for each sprite count we have set up, we want to go ahead and instantiate a scene. And we want to make sure that we set the position to be a random position, so it's just a little bit more randomized. So we make a sprite variable, which is just going to instantiate the dynamic sprite. And then we want to add the child over to our scene here. And then we want to set the position to be random, as I've said before, which we can do by going ahead and using the randf range function, which just goes ahead and gets the spawn area and then the X value. divided by 2, and then the spawn area x divided by 2 as well. So what this does is it'll go ahead and choose between a negative value of this calculation and a positive value of that calculation. And then we want to do the same but for the y value. So we just copy and paste, but we change the x to y. And that's already it for this function right here. So now we can actually test out all of this code. But first we'll need to add a comma here so that our code actually does not give any errors. Then what we can do is we can simply hit F5. If you get this pop-up, you just have to select current. And now we can see that we have some random sprites set up here. And as you can also see, as the further we get away from a sprite, we can see the sizes changing. So now when we just move around everywhere, the sprites will just get deleted if it's outside of the screen, as you can see on the right there. But as we get closer, or as we get further away, we can see the sizes decreasing. For instance, right here, we go further away, we see the size going to the lowest resolution, which is 64 by 64. And then as we get closer, it just ups in size. And also, as we can see, if we go all the way to the left here, we see all the sprites being destroyed on the right because it's going outside of our viewport as we have set up. So in this example, I have 2700 FPS, but if you were to use your own game, it'll probably already be lower because there are way more textures and sprites involved than just these different sprites here. But with the optimizations, we can see we're hovering around 2700 to 2900. And we even hit 3000 as we get farther away and as more objects get destroyed, right? Alright, so that's it for today's optimization tutorial. So now we have learned how we can implement dynamic resolution for sprites, add efficient culling, so when it goes off the screen the texture just goes away. And this causes the game to be significantly improved in performance, and it also optimizes memory usage. So don't forget to like and subscribe for more Godot tutorials. And also, you can download the example project in the description down below if you want it and if you want to use it for yourself. And also, if you have a question, join the Discord. I have a community right there that's happy to help you, and I am also happy to help you over there. And leave a comment if you have any other questions. So I'll see you next time. Bye bye.